Okay, hi guys, welcome to our first lecture in Calculus 3. So, this would just be a continuation of our lessons from Calculus 2. Okay, and for our first lecture in Calculus 3, we would be discussing sequences and then infinite series. Okay, so what do we expect from this module? So, from this module, we will learn how to find the terms of a sequence, find the formula of a sequence, and define, i-define muna natin o bago natin i-determine kung ano yung convergence and then yung divergence ng isang sequence. And then next, we will be finding the limit of recursively defined sequences. Okay, so let's proceed now. So, uh, we will introduce the topic of infinite series, no? So, usually kasi, di ba, for example, we have this value below. So, we have pi over 4. So, si pi over 4 pala, pwede nating isulat as a sum and difference of infinite number of numbers. Okay? So, we have 1 minus 1/3 plus 1/5 minus 1/7 plus 1/9, etc. So, itutuloy-tuloy natin yan eventually as we approach infinity. So, pag tinuloy-tuloy natin yan, ma-approximate natin yung value ni pi over 4. And then next, we have cosine squared. So, si cosine squared pala, mas nakaka-amazing to, no? Kasi si cosine squared pala, ay pwede nating isulat as a sum and difference of, para siyang, polynomial. Para siyang isang polynomial because we have x squared, x raised to 4. So, cosine x is just equal to 1 minus x squared over 2 plus x raised to 4 over 24, etc. Okay? So, paano ba natin to i-discuss? Paano ba natin siya sisimulan? So, lahat naman tayo alam mag-add ng dalawang numbers, di ba? Or yung iba, tatlo, apat. Okay? Pero paano tayo pag mag-add naman tayo ng sobrang dami na numbers, yung infinitely many numbers, Okay? So, sa chapter na to, sasagutin natin yon kung paano hanapin tong infinite sum na ito. Okay? So, pag-aaralan natin yung theory of infinite sequences and then series. Okay? Di ba, kung natatandaan nyo dun sa Calculus 1 at saka Calculus natin, very important yung limit. So, again, magagamit na naman natin siya dito, Kasi nga, meron tayong values na tinitake natin as a certain number approaches infinity. Okay? Okay. So, isa sa mga applications ng series ay nangyayari sa pagko-compute ng mga mahihirap na functions, Okay, so for example, ito yung cosine x. Cosine x pala parang, di ba sa trigo, hindi naman natin alam kung ano nga ba si cosine x, lalo na nung na-introduce sa atin yon. Okay, but by using series or infinite sums, naisulat natin si cosine as an infinite degree polynomial. Okay? Using the first few terms of the infinite series, we can allow for highly accurate approximations of functions by polynomials. So, magagawa natin na padaliin, okay? So, yung pag-compute kasi nga, gagamit na tayo ng mas general na functions such as the polynomials. Okay? So, usually daw, sa math daw, yung series at saka yung sequences ay napagpapalit. So, magbigay lang muna tayo ng distinction, Okay, so a sequence is a type of infinite list. Pag sinabi nating sequence pala, listahan lang siya. And then, pag tinake natin yung sum ng mga numbers na nasa listahan na yun, numbers or expressions, pag kinuha natin yung sum, it will become a series or an infinite sums. Or an infinite sum. Okay? Sige. Okay, so let us first formally define what a sequence is. So basically, sequence is a list of numbers. So we write them as a sub 1, a sub 2, a sub 3, etc. a sub n, and so on, so forth. Okay? So usually sequences are given in order. Bakit kailangan in order? Para makahanap tayo ng tinatawag natin na nth term formula. Okay, nth term formula. Okay, so itong mga A1, A2, A3 na to, siya yung ating mga terms. Okay? And then yung nakikita mong 1, 2, 3 hanggang kay n, yun naman yung tinatawag natin na index. Okay? So, yeah. Okay, so we can think of sequences as the following. So, pwede natin siyang isipin na isa siyang function na C1. Okay, so C1, minamap niya, sorry, minamap niya kay A1. C2, minamap niya kay A2. C3 kay A3 and so on, so forth. Hanggang kay si N, minamap niya kay A sub N. So, si A sub 1 hanggang kay A sub N, sila yung ating mga terms. Okay, and then ito yung ating mga index. So, para lang siyang function, no? So, naaalala nyo yung definition natin ng function. So, basically, a function is a mapping. Okay? So, sabi dito, an infinite series of numbers is a function whose domain is the set of positive numbers. So, yung nakita nyo kanina, yung 1, 2, 3, 4, 5, 6. So, kung yun yung domain natin, those belong to the set of positive integers. So, 1 up to infinity. Okay, so we have here an example. The function associated with the sequence. So, we have, ito yung sequence natin, no? 2, 4, 6, 8, 10, etc. Hanggang kay 2n and itutuloy natin. So, basically, si 1 na imap kay 2, si 2 na imap kay 4, and so on. So, madali lang naman na i-deduce na yung formula niya ay a sub n is equal to 2n. Okay? So here we can change the index to start at any given number. For example, the sequence. Ito. 12, 14, 16. So parang in-adjust natin siya, no? So, what then do we do? Paano natin i-determine yung formula na to? Note that, so, 2 naging 12. So, si 4 naging 14. So, basically, nagdagdag lang tayo ng 10. So, we can easily determine that the nth term formula or the formula for this sequence is 10 plus 2n. Okay? Basically, function, para lang siyang function talaga. Hinahanap natin yung function na nagre-result dito. Pero instead of instead of several points, ang kino-consider lang natin na input values ay set of positive integers. Okay? Okay, so another way of writing these sequences, pwede rin naman natin siyang isulat as b sub n equal to 2n pa rin. Pero this time, i-specify natin or sasabihin natin na n equals 6, 7, 8, and so on, so forth. So, minove lang natin yung index natin. So, possible yun. Possible din naman na gawin yun. Okay? Okay, so here we have a few examples of sequences. Okay, so we have a sub n equal to the square root of n. B sub n is equal to negative 1 raised to n plus 1 all over 1 over n. Okay, so ito may special tawag dito. Ang tawag natin dito ay alternating series. Bakit siya alternating series? Kasi meron tayong multiplier na negative 1 raised to n plus 1. So, alternating kasi nag-alternate yung sign natin. Okay, depende kay n. Okay, kasi magsisimula tayo kay negative 1 raised to 2, magiging positive 1. Pag raised to 3 na, magiging negative 1, magiging positive 1. Okay? So, nag-iiba-iba talaga yung value niya. Kaya siya tinawag na alternating series. Okay? Or, alternating sequence. And then next, we have c sub n equal to n minus 1 over n. And then we have, again, an alternating sequence which is negative 1 raised to n plus 1. Okay. So, bukod dun sa numbers na pinakita kanina, we can actually write sequences in terms of points on a graph. Okay? So, the function is defined only on integer input. So, yun sinabi ko kanina, instead of, di ba meron tayong mga, for example, iti-take pa natin dito. Pag magra-graph tayo, for example, etong graph na ito, hindi lang tayo integer yung titignan natin, di ba? Usually, pag magra-graph tayo, kukunin pa natin si 1.5, 2.5, 3.5, 4.5 para maging accurate. Pero pagdating sa sequences, we only take positive integers which is 1, 2, 3, 4. and 5. Okay, same goes with the other examples, no? So this one is the graph of a sub n equal to square root of n, a sub n equal to 1 over n, and then a sub n minus negative 1 raised to n plus 1. Okay? Sige. And these functions usually approach a certain value. Okay? So, pwedeng may ina-approach siya, pwedeng wala. And this is what we call divergence and convergence. Pag yung isang sequence or yung isang series ay merong ina-approach na number, we say that it is convergent. And kung wala naman, it is divergent. Okay? Sige, proceed tayo. Okay? What is convergence and divergence? Okay, so, sige. Let's look at the first sequence. Sige, tingnan natin. Ito kaya, pag in-approach ni n si infinity, what happens? So, the denominator approaches infinity, so it gets infinitely bigger. So, the bigger your divisor is, the smaller the number you have. Okay, kasi nga, 1 divided by a really big number approaches 0. So, this one is convergent, and ang ina-approach niya ay 0. Tama? Okay, next one is we have 0, 1/2, 2/3, 3/4, 4/5, etc. hanggang kay 1 minus 1 over n. Ito naman kaya, ano kaya ina-approach nitong series na to? Okay, we start with, sige. As n gets bigger, this number approaches 0. So, we are left with 1 minus 0, or 1 minus a really small number. And as we let n approach infinity, liliit lang liliit to, we approach the number 1. So, this one is also convergent, but this time it approaches the number 1. On the other hand, we have sequences like these two na walang ina-approach, no? So, this one, we have negative 1, we have square root of 1, square root of 2, etc. Square root of a really big number is still a really big number. Okay, so basically, wala tayong makukuhang limit niya, no? Okay, so wala siyang ina-approach na value. So, it is divergent. Okay? And the third one is, again, the alternating series. So, yung function na to, nagsasalita na lang from 1, negative 1. So, basically, kung i-graph mo yan, magiging itsura niya ay pag ganito. So, basically, walang ina-approach na value. So, again, it is divergent. Okay? So, napag-aralan naman na natin, no, pag plinat, parang pag titignan nyo yung function niya, the limit does not exist. Okay? So, pag the limit exists, then we say that the series is convergent. Okay? So, sige. So, balikan natin tong concept na to. No? So, let us formally define what convergence and divergence is. Okay? So, kung naaalala nyo pa to, nung calculus 1 natin, di ba dinefine natin si limit? Calculus 1 ba or calculus 2? Calculus calculus 1 or 2, something like that. So, we defined the limit in terms of two numbers. Meron tayong epsilon and then meron tayong number n. Okay? So, ito yung definition ng convergence at saka divergence. The sequence, a sub n converges to the number L. So, L here is the limit. If for every positive number epsilon, there corresponds an integer n such that the absolute value of a sub n minus L is less than epsilon whenever n is greater than n, or big N. Okay? So, ano bang meaning nito? Okay? So, if we have an epsilon or a really small number epsilon, we say that a sub n approaches L if the difference of a sub n and L remains smaller than that particular epsilon. Okay, smaller than this particular epsilon whenever n is greater than n. So what this means is, pag pinalaki pa rin natin ng sobra si n, okay, this difference will stay smaller than epsilon. Only then when we say that a sub n approaches L. Okay? Kung walang number L or walang limit na nag-exist, then we say that the sequence diverges. Okay? If a sub n converges to L, then we write the following. So, recall lang naman to kasi na-discuss na natin sa previous lessons. limit ng a sub n as n approaches infinity is equal to L. Or simply we write a sub n approaches L and call L the limit of the sequence. Okay? So, ayan nga, sabi dito, popular na daw yung definition kasi nga nagamit na natin siya when we define the limit of a function as x tends to infinity. Okay? So, sige, we'll try this on a few examples. Okay? So, we show that the limit of 1 over n is equal to 0 and then the limit of k is equal to k, both as n approaches infinity. So, kailangan nating humahanap ng epsilon, okay? Epsilon, tama. Okay? So, let n, wait lang, magsusulat lang. Okay, so let epsilon, a muna tayo let epsilon be greater than 0, given. Okay, we must show that there exists, so this symbol is there exists an n integer such that 1 over n minus 0 is less than epsilon whenever n is greater than n. Okay, so don't be confused by the symbols So this one is just equal to there exists, okay, and then n, variable yan, is an n na element ng set of integers. Okay, actually, yeah. Okay, so now we have the inequality. So first take a look at this inequality, so taking a look at this inequality, this will only hold if 1 over n is less than epsilon, and this one can be written as n greater than 1 all over epsilon. Okay, so if any n is any integer than greater than 1 over epsilon, then the inequality will hold for all n greater than n. Nagigets ba? So, eto, sige, paliwanag ko ulit. Eto, magho-hold lang siya whenever 1 over n is less than epsilon. Tama? Kasi nga, 1 over n minus 0 lang naman to Right? So, si 0 pala dito ay yung limit natin, So, parang bine-verify lang natin, So, 1 over n minus 0 is just equal to 1 over n. And then, the absolute value of that, okay, is just 1 over n. Kasi nga, n is a positive number. So, 1 over n is less than infinity. This means that n will always be greater than 1 over epsilon. So, if we take n to be any integer, or if we take n to be any integer greater than 1 over epsilon, okay, then the inequality will hold for all n greater than n. Nagigets ba? So this means that it is true that the limit of 1 over n is equal to 0 as n approaches infinity. Okay, what about the second one? So sa B naman tayo, B. Let epsilon be greater than 0 pa rin. Kung kailangan kasi positive number siya. We must show that there exists an integer n. So ganun pa rin naman yung formula. Show that there exists an integer n such that, okay, so k minus k is less than epsilon. Okay? Whenever n is greater than n. Again, balikan natin yung definition ng limit, So, kaya siya na-form. So, si k natin dito, siya rin kasi yung limit natin. Okay? Okay. So, tayo medyo obvious naman kasi, sir. Obvious naman. Ba't pa kasi natin pinuprove? Kailangan kasi minsan bumabalik tayo sa basics para mas maintindihan natin. Okay? So, since k minus k, so this value is equal to 0, we have 0 is less than epsilon. But we know that epsilon is a positive number. So, hindi siya nakadepende sa value ni small n. So, regardless of the value of n, we will have 0 to be less than epsilon. Kasi nga, sinet natin si epsilon ay greater than 0. So, ayun, for any value of n we take, so, mag-hold yung ating inequality na ito. Okay, which proves that the limit of k as n approaches infinity is still equal to k. Okay? Okay. For tayo, okay. Next one. Ito ba? How do we show that this one is divergent? So, sabi natin divergent siya pag wala tayong makuhang epsilon, right? How do we show that wala tayong makuhang epsilon? Kailangan pa ba natin? Parang medyo obvious naman na, no? Pero sige, let's try. Suppose natin na nagko-converge nga siya sa isang number L. Bali, ano to, parang proof by contradiction, ano. Suppose natin na, kunwari convergent siya and then maghahanap tayo ng inconsistency. Okay, so suppose that this sequence converges to a certain number L. Hindi natin alam kung ano yung L na yun. Pero hindi natin, ano ba, paano ko ba sasabihin to? Hindi siya pwedeng mangyari na mag-approach siya kay L kasi nga alam natin na 1, -1. So, if we plot this one, magiging 1, -1 or di nga ganyan magiging 1, -1, 1, -1, 1, -1. So, nagsasalitan siya. So, how is there supposed to be a limit? Okay? So, sige, try natin. If we choose epsilon to be greater than 1/2 or choose epsilon to be greater or to be equal to, sorry, let's do this again. We choose epsilon to be equal to 1/2. Okay, dun sa definition ng limits natin. Therefore, all the terms a sub n should be within epsilon equal to 1/2 of L. What does this mean? For every a sub n, so bawat term ng ating sequence, pag minus natin sa L, kailangan less than 1/2. Pero is this possible when the value of our function keeps on oscillating from 1 to -1? This one is impossible. Okay? So, this same argument would work for any possible epsilon greater than smaller than 1. Okay? Pwedeng hindi naman 1/2 I-take natin si epsilon equal to 1/3. Ganun pa rin yung mangyayari. Maski paliitin natin ng paliitin si epsilon, yung difference nito at saka ito ay hindi papasok doon. Kasi nga, nag-oscillate yung function natin. Okay? Okay, don't worry. Sige. Hindi naman ako magbibigay ng ganitong klaseng problem sa mga exercises nyo. Kung meron man, ay sobrang dali lang rin. Okay? Okay, so the sequence, sorry, I think this is a typo. So the sequence square root of n also diverges. Paano naman masasabi to? Because as n increases daw, its terms become larger than any fixed number. Okay, kasi nga si square root of n nag-approach ng infinity. So hindi tayo makakahanap ng epsilon na magko-contain sa difference ng limit at saka ng isang infinitely approaching number. Okay, that's why we say that the limit of the square root of n is equal to infinity. Okay? Okay, so on a side note, when we say that the limit of a sequence is infinity, hindi naman natin sinasabi na, kumbaga pag minus mo yung number na yun sa infinity, or as that number approaches infinity, lilit yung difference niya. No. What we mean is that given a certain number, a certain m or a certain L limit, that our sequence a sub n, the sequence of a sub n stays larger than that number. Okay? So yung definition niya. We can take a look at this graph. So ang nakikita nyo, ito. Okay, so we are not aware or hindi natin alam kung saan talaga pupunta tong number na to, kung totoo bang mag-approach na infinity. So when we say that the sequence approaches infinity, what we mean is this. Hindi meaning nun na ito ay tataas ng sobrang laki. What we actually mean is that whenever we take a number m, okay, or any L, number m, the sequence values will remain greater than that m. Same goes with this one, pag negative infinity naman. There exists a small m such that mananatiling mas mababa dun sa m na yun. Okay? Now, in this case, we say that it approaches negative infinity. Okay? As n approaches positive infinity. Dito din, as n approaches positive infinity. Okay? Yun lang gusto niyang sabihin doon. Okay, so we have this one. The sequence a sub n diverges to infinity if for every number m there is an integer n such that for all n greater than big N, a sub n is greater than m. If this conditions holds true, we write the limit of a sub n to be equal to infinity, or a sub n approaches infinity. Similarly, if for every number m there is always an integer n such that for all n greater than n, we have that the a sub n's are less than m, then we say that the sequence diverges to negative infinity, and we write the limit of a sub n is equal to negative infinity as n approaches infinity, and so on. Okay, so usually, parang na-discuss naman na kasi talaga natin ito sa Calculus 1 at sa Calculus 2. Okay? So we have another side note. The sequence may diverge without diverging to infinity or negative infinity, as we're saying. Okay? So makikita, 'di ba sinabi natin kanina yung alternating series, nag-alternate lang siya from negative 1 to 1. Okay? Pero consider natin siya na divergent kasi nga hindi siya nag-approach sa isang single number. Ganon din sa mga sequence na to. 1, negative 2, 3, negative 4, 1, 0, 2, 0, 3, 0, 4, etc. So, pag sinabing divergent, hindi kailangan infinity yung ina-approach niya. Okay? So, how do we calculate the limits of the sequences? We have theorem 1 here. Suppose that the limit exists. So, the limit of a sub n and then the limit of b sub n exists. We have the following rules, some rules. Okay? So, the first rule is just says that the limit of the sums is just the sum of the limits. And then same goes with the difference. The limit of the difference is the difference of the limits. Okay? What about constant multiple rule? Pag sinabi natin constant nag-multiply tayo ng constant, pwede lang natin ilabas yung constant and then we take the limit of the function and then we will get that the value we want. When it comes to the product rule, the limit of the products is the product of the limits. Okay? And then here, pareho lang rin, the limit of the quotient is the quotient of the limits given that b is not equal to 0. Okay? Kailangan b is not equal to 0 kasi we cannot divide a number by 0. Okay, so we have example 3. By combining theorem 1 with the limits of example 1, we have the following. So, ang ginamit natin dito ay si quotient rule. Nilabas natin si negative 1, kaya nagkaroon tayo ng ganito. And then, nagkaroon tayo ng, pwede natin gamitin si, so, ginamit natin si constant multiple rule para ilabas si negative 1. And then, pwede natin gamitin si quotient rule. Ang limit ng 1 as n approaches infinity ay 1. Okay, divided by a really big number. The limit of n as n approaches infinity is infinity. So 1 over infinity is 0. So we have negative 1 times 0 is equal to 0. Okay, so product rule na yung ginamit natin dito, or constant multiple rule. Okay, next, difference rule ang ginamit din dito, and example 1a. Okay, so difference rule. So dinistribute lang natin si n, no? Okay, so we get n over n minus 1 over n. So the limit of 1 as n approaches infinity is still 1. So we get this one. But the limit of 1 over n as n approaches infinity is 0. So we get the limit to be equal to 1. Okay. So tandaan nyo pala na any limit na na-discuss na natin, pwede nyo nang gamitin sa mga next na solutions nyo. Okay. Hindi nyo na kailangan ipakita ulit na the limit of n minus 1 over n is 1. Okay, understood na yun. Basta, nasolve na natin. Kailangan nyo na lang i-cite according to example 3, blah, 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 blah. Ganyan. Next, we have that the limit of 5 over n squared is equal to 5 times the limit of 1 over n. So, dito ang ginamit natin ay si the product rule saka si constant multiple rule. So, nilabas natin si 5 kasi nga constant siya. And then, si 1 over n squared, pinactor natin siya sa 1 over n times 1 over n. Bakit pa natin kailangan gawin, sir, yun? Yung n squared nag-approach ng infinity. Hindi pa natin alam yun. Pero alam natin that the limit of 1 over n as n approaches infinity is equal to 0. So, pwede natin gamitin yung fact na ito. Kaya natin siya hinati. So, alam natin, ito 0, ito 0. So, we have 0 times 0. We have 5 times 0 times 0 is equal to 0. And then last but not least, we have this one. So, how do we do this? Pwede nating i-simplify. So, meron mga ganitong limit, ano. Na encounter nyo naman ito. I-simplify natin siya by dividing it by the greatest factor, which is n raised to 6. Okay, dividing or tama, multiplying this value by n over dividing by n over 6 yung denominator at saka yung numerator, we will arrive at the following value. Mas madaling kunin yan. Kasi ito magsi-0, ito magsi-0. We are left with negative 7 over 1 which is equal to negative 7. Okay? So, medyo repetitive lang pero instead of functions, yung tinetake natin ng limits, ang tinetake na natin ng limits ay sequences. Okay? Ito, familiar rin to, the sandwich theorem. Okay? So, suppose we have 3 sequences and then yung and kung meron tayong a sub n is less than or equal to b sub n less than or equal to c sub n and si a sub n at saka si c sub n ay pareho ng limit, yun na rin yung limit ni b sub n. Kasi napagitnaan siya kaya nga siya tinawag na sandwich theorem. Okay? Okay. An immediate consequence, so base dito pwede nating masabi to. Suppose if the absolute value of b sub n is less than c sub n, tapos si C sub n nag-a-approach sa 0, matik si B sub n mag-a-approach din sa 0. Paano natin nasabi yun? Kasi nga, alam natin to Mas maliit si B sub n kay C sub n. Tapos ito 0. The meaning, 0 din yung limit ni B sub n. Okay? So we have this, the sample na application ng squeeze theorem o sandwich theorem. So, we know that cosine n over n is less than 1 over n and less than negative 1 over, n is greater than negative 1 over n. How do we know this? Kasi alam natin na si cosine n naglalaro lang naman from 1 to negative 1. Okay, since this limit is 0 and this limit is 0, we know that cosine n over n approaches 0. And then same goes with this one. We know that 1 over 2n will always be positive and thus greater than 0 but less than 1 over n. Since the limit of 1 over n is 0 and the limit of 0 is 0 as n approaches infinity, we have the limit of 1 over 2n is infinity as well. How about this one? Okay, this one is 0 as well din. Bakit? Kasi it is between negative 1 over n and 1 over n. Kasi nga, we have this factor, negative 1 raised to n, which is just an alternating factor na nagpapalit-palit from negative 1, 1, 1, negative 1. Ganun. Parang papalit-palit lang siya. Okay. Next, we have the following identity. Pwede nyo itong gamitin, no? If the absolute value of a sub n approaches 0, then a sub n approaches 0. I think, discuss na natin to pero sinabi natin siya na absolute convergence rule ata yun from early calculus, okay? Because we have that then negative of a absolute value of a sub n is less than a sub n, which is less than the absolute value of a sub n, okay? Okay, so we have another theorem. Let a sub n be a sequence of real numbers. So if ang limit ng a sub n as n approaches infinity is L, and kung meron tayong continuous na function sa limit na yon, note that continuous dapat siya, then the limit of a sub n, f of a sub n as n approaches infinity is equal to f of L. So, parang sinasabi lang niya to na pwede nating ipasok yung limit sa continuous functions. Okay, so in this case, yung function natin na ay si f. Okay, show that the square root of n plus 1 over n is approaches 1. Okay? So, ano yung f natin dito? I think our f here is what? Our f of x here is equal to the square root of x. Is the square root of x continuous on 1? Yes, because we know that the graph of square root of x is continuous. Yeah, it is continuous. Pag ganun yung itsura ng graph niya. Okay, therefore we can apply the continuous function theorem. Okay, so what this means is that since we know that the limit of I think yung previous na discussion natin, okay, we know that the limit of n or plus 1 over n is equal to 1. Therefore, yung f of or limit ng f of n plus 1 over n, which is equal to the limit of the square root of n plus 1 over n, is just equal to f of 1, which is equal to 1, or square root of 1, which is equal to 1. Okay, as n approaches infinity. Okay, yeah, ganun din dito sa example 6. The sequence 1 over n converges to 0 by taking a sub n to be equal to 1 over n, and then yung function natin ay 2 raised to x. Okay? Okay. Using L'Hopital's rule, I think na-encounter na rin natin to. Okay? Okay, so theorem 4. Suppose that we have a function f of x that is defined for all x greater than n sub 0, and that a sub n is a sequence for real numbers such that a sub n is equal to f of n for n greater than n naught. Then, the limit of the a sub n is equal to L whenever the limit of f of x is equal to n. This can be better seen pag ginamit natin siya sa applications. Okay, so we know that we need to take the limit of ln n, so yung natural logarithm ng n, divided by n as n approaches infinity. Kailangan natin ipakita na equal siya kay 0. Okay, so our function here can be written as ito, ln x divided by x. So, alam naman natin to na define siya for all x greater than 1. Okay? And then, this function satisfies our sequence for all positive number n. So, ito ay pareho lang neto pag ang tinik lang natin niya ay integers. So, by our previous theorem, we know that the limit of ln n over n will be the limit of ln x over x as x approaches infinity. Okay? Kung nag-exist to. Kung hindi to nag-exist, hindi natin pwedeng hanapin to, or hindi tayo pwedeng mag-conclude sa limits niya. Alam natin na nag-exist. Okay? Via the L'Hopital's rule. So what the previous theorem was saying is that we can use the L'Hopital's rule to find again the sequence or the limit of the sequences. Okay, so kung natatandaan nyo to, ano ba ang limit ng ln n? 0 and the infinity, and then the limit of x is infinity as well, so we can apply the L'Hopital's rule. Paki-recall na lang, no? Okay, so since infinity over infinity, applying L'Hopital's rule, i-derive natin. Derivative of ln x is 1 over x, and then the derivative of x is x. So taking the limit, this one becomes 0, and the limit of 1 is just 1, so we have 0 over 1, we have 0. Okay? So, pwede natin palang gamitin si L'Hopital's rule para i-compute yung limit. Okay? So, on a side note, when we use L'Hopital's rule to the limit of the sequence, we often treat n as a continuous real variable. Okay? So, parang treat lang natin siya as a function, not as something na as a function, not as a points on a sequence. Okay? Parang trinatrato natin siya na functions. Okay? So, how about this one? Okay, how about this one? Okay, so we have a sub n to be equal to n plus 1 all over n minus 1 raised to n. Okay, yung nasa loob, ang limit niya ay as n approaches infinity is just equal to 1. Okay, and then ang limit naman nito ay infinity. So, meron tayong 1 raised to infinity. So, indeterminate yung form natin, which means pwede natin gamitin si L'Hopital's rule. What does L'Hopital's rule say? Pwede tayong mag-derive. Okay. Okay, so to apply the L'Hopital's rule, kailangan muna yung isa sa dun sa mga forms na naka-indicate. So, kailangan muna nating ipakita that it is of the form infinity times 0. Again, kung natatandaan nyo pa, meron tayong ibang indeterminate forms, si infinity over infinity, si 0 over 0 over 0. So, lahat yun pwede natin gamitan ng L'Hopital's rule. Okay? So, we take the natural logarithm both sides. So, the ln of a sub n is just equal to the ln of n plus 1 all over n minus 1 raised to n. By logarithm rules, pwede nating i-bring down si n. Okay? Ngayon, yung limit na natin ay the limit of a sub n is equal to infinity and this one approaches 0. Okay? So, meron na tayong this one approaches 0 and this one approaches infinity. Okay? So, pwede na natin gamitin yung L'Hopital's rule. Okay? So, ide-derive natin tong nasa taas. Okay? So, magkakaroon tayo ng ln over n ln ng n plus 1 all over n minus 1 all over 1 over n. Since ito, ang limit nitong nasa taas ay 0 and ito rin ay 0, L'Hopital's rule ulit tayo. Okay, so we have negative 2 all over n squared minus 1 all over 1 minus n squared. Ito ba? Magkakaroon pa rin tayo ng 0 over 0, no? So, pwede pa rin nating i-derive. So, deriving the numerator and then the denominator, we have 2n squared all over n squared. So, dito, I think pwede naman na tayo mag-stop. We can bring down, or pwede natin itong i-simplify. Pwede tayo maglabas ng n squared. So, magkakaroon tayo ng 2 all over 1 minus 1 all over n squared. This one approaches 0, so we are left with 2 over 1, kaya nakuha natin si 2. Okay. Since we know that, okay, so balik tayo dun sa original natin na problem, no? Since we know that ln of a sub n approaches 2, so base dito sa previous na computation natin, and we know that e raised to x is continuous, we have that a raised to n which is equal to e raised to ln a sub n approaches e raised to 2. Kasi ang limit ng ln a n ay 2. Okay? Therefore, the sequence a sub n converges to e raised to 2. Okay. So, ito yung mga, I think yung iba dito na compute na natin. So, whenever we encounter these limits, hindi nyo na siya kailangang i-prove, no? Kasi na-discuss na natin siya. So, we have that the limit of ln over n is 0, x raised to 1 over n is equal to 1. Okay. Note that di ko na sinasabi yung limits, kasi understood naman na sana dito sa lesson natin na infinity yung ina-approach natin. Then, the limit of 1 plus x raised to n is equal to e raised to x, etc. Okay, so we just have a few applications of this theorem. So, ln n squared over n is the following. So, ang ginamit ay si Formula 1. Ito naman example for Formula 2. Hindi ko na siya isa-isahin kasi we're already 43 minutes into our lesson. Pwede nyo naman siyang i-post. Okay? Okay, next we have another type of sequence. So, a sequence that is recursive. Pag sinabi natin recursive, nakadepende siya sa initial terms or dun sa mga terms bago siya. Okay? We call this a recursive formula. Okay. So, bigay tayo ng examples. Okay, so we have this one. So, the statement, yung unang term ng sequence natin ay a sub 1. And then, a sub 1 equal to 1. And then, yung sa mga sumunod na terms, ganito na. A sub n minus 1 plus 1 for all n greater than 1. So, paano natin nahanapin si A2? Si A2 pala ay equal kay A sub 2 minus 1, which is 1 plus 1, which is equal to 1 plus 1 is equal to 2. So, kung hahanapin natin si A3, nakadepende siya kay A2, which is 2 plus 1. Tama? Kung hanapin natin si A4, nakadepende siya kay A3 plus 1. Okay, kaya siya tinawag na recursive. Hindi mo pwedeng mahanap yung future terms without using the previous terms. Okay? Okay, and then another example, ito naman ay multiplicative. So, this one defines our factorials. Okay? Kasi nga, so kung yung first term mo ay 1, then Base sa formula na to, itong a sub n equal to n times a n minus 1. Yung susunod na terms ay 1 times 2. Then yung third ay 1 times 2 times 3. Then yung fourth 1 times 2 times 3 times 4. Okay, until eventually we get to the factorial. Okay, then next is yung pinaka-famous na na sequence natin na recursive, which is si Fibonacci numbers. Okay, wherein nakadepende dito naman, recursive siya in a way na nakadepende siya sa dalawang number. Dalawang previous number bago yung next number. So we have 1, 1, 2, 3, 5. Okay, so 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. Okay, so dalawang numbers yung nakadepende sa kanya. Okay? And then here we have another example that we get when we apply Newton's method. Okay? So, dito ang initial term natin ay x sub 0 equal to 1. And then yung mga next terms natin ay defined by x sub n minus sin x sub n minus x sub n raised to 2 all over cosine x sub n minus 2x sub n whenever n is greater than 0. Okay? Okay. Okay, so we have a new definition lang naman, no? Bounded monotonic sequence, okay? So, pag sinabi nating bounded, meron siyang harang, ano? So, we have two types of bounds. So, a sequence is bounded from above kung merong number m such that any term in the sequence is less than or equal to m, okay? And then, kung meron tayong upper bound na m, and then wala nang iba pang upper bound ng a sub n, okay, na mas mababa kay m, meaning si m natin ay least upper bound. Okay? And then, a sequence is bounded from below naman kung meron kang small m such that lahat ng terms sa sequence mo ay mas malaki kaysa dun sa small m na yun. Okay? Kung wala nang number na mas mababa kay a sub n, or wala nang number na mas mababa kay m, such that a sub n is greater than equal to m, we say that m is our greatest lower bound. Okay? Okay, so if a sequence is bounded from above and bounded from below, then a sub n is bounded. Okay, kung hindi siya bounded, then we say that it is unbounded. Okay? Okay. Bigay tayo ng example. Si 1, 2, 3, etc. And so yung sequence natin ng positive integers ay hindi bounded. Kasi wala tayong mahanap na number n such that lahat ito ay mas mababa sa kanya. Okay? Same goes with, hindi naman pala. This one is, meron siyang upper bound. Okay? So 1/2, 2/3, 3/4. Okay? So ang upper bound niya ay no matter how far we go, yung yung denominator natin ay mas malaki pa rin ng isa kaysa sa numerator natin. Let me say that again. Yung denominator natin ay mas malaki kaysa sa numerator natin. So never siya mag-exceed ng 1, which means that an upper bound is m equal to 1 and it is the least upper bound. Okay, naging least siya kasi note that this one is less than 2 as well. Pero si 2, hindi naman siya yung pinakang upper bound natin eh. So it's just an upper bound but it is not the least upper bound. In the case of 1, wala na tayong mahahanap na mas mababa pa kay 1 such that binabound niya yung mga terms ng sequence na to, which means that m equals to 1 is the least upper bound. Okay, so one problem we have is hindi porke bounded yung ating function ay nagko-converge na siya. Okay, kaya naman so yun lang naman yung basically gustong sabihin nitong slide na to, no? Okay? Kaya kailangan nating introduce yung isang term pa or isang set of terms para ma-determine talaga yung convergence. Okay, kasi nga 'di ba for example yung series natin kanina, negative 1, 1 yung ano ang itsura niyan, ganyan, raised to n. Ang sequence na to ay negative 1, 1, negative 1, 1, etc. Okay? So itong series na to ay bounded ng 1 at saka ng bounded from above ng 1 and then bounded from below ng -1. And ito ay least upper bound and ito ay greatest lower bound. But even so, hindi na, 'di ba sabi natin ito ay divergent. So hindi natin siya pwedeng sabihin na convergent siya. So boundedness does not mean or does not equate convergence. Okay, so which is why we introduce new terms, the as monotonic, or we define what a monotonic sequence is. Okay, so a sequence is non-decreasing if a sub n is less than a sub n plus 1 for all n. Okay, so non-decreasing, yeah, less than or equal. Note that hindi natin sinabing increasing non-decreasing does not mean increasing kasi pwedeng maging constant naman siya. Okay, and then the sequence is non-increasing if a sub n is greater than or equal to a sub n plus 1. So ito naman yung hindi rin natin siya sinabi na decreasing. We use the term non-increasing kasi nga possible naman na mag-stay constant. Okay? So, if it is either non-decreasing or non-increasing, monotonic yung tawag natin sa kanya. Okay, so the sequence 1, 2, 3, etc. has no upper bound. Okay. Mali yata ako ng insert dito. Okay. So, the sequence 1, 2, 3 hanggang kay n is non-decreasing. This one is non-decreasing as well. Kasi papa-increase, even though bounded siya ng 1, non-decreasing pa rin siya. Okay? Or increase. Tama, non-decreasing pa rin. And then, this one is non-increasing. Kasi nga, as n gets larger, lumalaki yung divisor mo, which leads to the decline of the value. And then next, ito yung sinasabi ko kanina, the constant sequence 333. So it is neither non-decreasing or non-increasing. Okay, so the sequence 1, -1, 1, -1 is not monotonic kasi hindi siya increasing, hindi siya non-decreasing, hindi rin siya non-increasing. So it's not monotonic. Okay? So, ito na yung definition natin, no? A non-decreasing sequence that is bounded from above always has a least upper bound. Likewise, a non-increasing sequence bounded from above always has a greatest lower bound. Okay? So, dito napapasok yung sinasabi ko kanina. Nagagamitin natin yung boundedness at saka yung monotonicness ng isang function. Okay? So, if L is the least upper bound of a non-decreasing sequence, then the sequence converges to L. If L is the greatest lower bound of a non-increasing sequence, then the sequence converges to L. Okay? Yan. Ito yung sinasabi. Monotonic sequence theory. If a sequence is both bounded and monotonic, then the sequence converges. So, para mag-prove ng convergence ng isang sequence, kailangan nyo lang ipakita na bounded siya, and then after nyo ma-prove na bounded siya, i-prove nyo rin na monotonic siya. Okay? So, take note daw dito, yung theorem natin na to ay hindi nag-a-apply or hindi niya sinasabi na yung convergent sequence natin ay monotonic. Basta ang alam lang natin, pag bounded at monotonic ay convergent. Okay? Hindi porke convergent ka, bounded and monotonic ka. For example, ito, -1 raised to n plus 1 all over n. Okay? Nagko-converge to sa 0. Am I right? Yes. Okay, and then bounded din siya ng ano kaya? 1, -1. Pero hindi siya monotonic since nag-alternate siya between positive and negative values. Okay? Yeah. So, I think that's it. So, basically, ang summary lang nito ay kailangan yung i-prove na bounded at saka monotonic. So, kailangan kayong humanap ng upper bound. So, in this case, upper bound or lower bound. And then, make sure that yung upper bound na nakuha nyo ay yung least upper bound. And then, yung lower bound na nakita nyo ay si greatest lower bound. Okay? Okay. And then, ipakita nyo na kung least upper bound yung nakita nyo, ipakita nyo na non-decreasing. Kung greatest lower bound yung nakita nyo, ipakita nyo na non-increasing siya. No? Okay, so I think that's it. So i-upload ko na lang ulit ito and then yung module nyo sa group natin. Thank you for listening.